Okay, hello everyone, welcome back. So in the last class, we have provided you with a brief introduction to data mining, and we also introduced that one of the important problems studied in the data mining area from the perspective of database systems is actually to mine the frequent patterns from the transaction records in the database system. And we also introduced some of the basic information about how to mine these frequent patterns, and we also introduced some concepts about these frequent pattern mining problems. If you still remember, in the last class, we also mentioned some properties we need to know about this mining the frequent patterns. So one of the property we need to know is about the downward closure property of the frequent patterns. In other words, any subset of a frequent item set must also be frequent as well, right? Another property we need to know is about a priori pruning principle. In other words, if there is any item set which is infrequent, then all its superset will be infrequent as well and will not be generated or tested, right? So these are two basic properties we need to know prior to introducing the a priori algorithm for mining the frequent patterns. And if you still remember, in the last class, we also provided with a brief introduction for the examples to use this a priori algorithm for mining the frequent patterns. So given the data sets, we can generate the item sets first. Then we can account the appearance of the item set in the database system, and also prune this infrequent item sets, right? Which will generate item sets containing one single item, right? And based on it, we can further generate a candidate set containing two items as candidates, right? And we can also scan the database system to count its appearances and also prune its infrequent ones. And then we can move to the candidate set with 3 items. Then we can generate the item set with 3 items and also do the further pruning, right, to find the frequent item sets with 3 items. So this is a general process for mining the frequent patterns with the a priori algorithm. So this is an example, right? So in this class, we plan to move to the formal description of this a priori algorithm, and we provide the pseudocode together with some descriptions how to use the algorithm for mining frequent patterns. And the algorithm will work exactly in the same way as we show in this example, but we will describe this process in a formal language with pseudocode instead. So in this page, we provide you with the a priori algorithm for mining the frequent patterns. In this algorithm, we use 2 notations. The first one is CK. It denotes a set of candidate items of size K, and we also have LK here. It denotes the set of frequent item set of size K as well. So according to the previous example, prior to the iterative mining process, we need to get the frequent item sets with one single item first, right, by scanning the database systems. So let's assume we have this L1 already. It contains the frequent item sets containing one single item, which are larger, the appearance is larger than mean support threshold. With this L1, we can do the iterative mining process to mine the frequent item sets with more items contained in them. So we will do the iterative mining with this for loop. In this for loop, we have this k as the iterator, right? It starts with value 1, and we will increase this k value 1 by 1, right, in each iteration. And the ending condition will be the LK is non-empty set. If this LK is empty set already, then we will stop, right? So inside the for loop, we have the generation step first. Based on this L we get from the previous loop, we can generate the candidate sets with this LK, right, which will be denoted by the CK plus 1 for the next loop, right? And this denotes the candidate set. And for each of the transactions we have in the database system, we will count the appearance of the item sets, these candidates in the CK plus 1, right? And then for each of the appearance, we will increase or increment the count of all the candidates in the CK plus 1 that contained in the T, right, the transaction in the database system. In this process, we can count the appearance of all the item sets in the CK plus 1, which can be denoted by the frequency, right? And based on this one, we can further prune this CK plus 1 with the mean threshold of this with this mean support threshold, which will generate this LK plus 1. It denotes the final set of the frequent item sets with k plus 1 size, right? And this process will continue iteratively until this LK is non-empty set. And finally, we will return all the union of the k starts from 1 until this ending condition. In other words, we will return all the frequent item sets of the size starting from 1 to the very end, right? Okay, so this is the algorithm we use for mining the frequent item sets or frequent patterns from the transactions. This algorithm is also very famous. It's called Apriori algorithm, and the Apriori principles will be used in the pruning process as well, and we'll provide you with more information for this part. So, according to the previous page for the Apriori algorithm, when we are implementing this algorithm, we need to have some function, right? The first part is how to generate these candidates from this LK, right? And how to generate CK plus 1, which will be very interesting actually. So, in this algorithm, actually, we can generate candidates via the self-joining together with pruning. This pruning is different from the pruning we use with the mean threshold. So this pruning is slightly different. It is pruning based on this a priori principles. So for generating the candidates, we have two steps. The first step is to do the self-joining with this LK to generate this CK plus 1. The second step is to do the pruning with the a priori principles. We can provide you with an example. What do we mean by the self-joining together with pruning? Let's assume we have the frequent item sets with size 3, L3 equals to ABC, ABD, ACD, ACE, and BCD. And we propose to generate the C4, right, or CK plus 1, C4 here. And we do this generation by two steps. The first step is to do the self-joining. We do the joining with the L3 joins L3, because we know the L3 already, right? So what does it mean by the self-joining? If we plan to join the ABC and ABD, we can join them together, right? The first one contains 3 charts, the second one contains 3 charts as well. However, this AB is shared by them, right? In other words, with ABC and ABD, we can generate one ABCD, right, from these two. At the same time, with ACD and ACE, we can also do the self-joining, which will generate a sequence or string with 4 charts ACDE, right? However, for some other strings, it will be very difficult to join them together. They probably will contain very different charts. In some cases, it depends. So the target is to generate some of the strings which will contain 4 items in the joining result, right? So you can check this part to make sure your self-joining will generate the candidates with 4 charts, which is based on the L3, this item patterns. Okay, so based on self-joining, then we can do one pruning actually, which is based on the a priori principles. I hope you still remember, right? For the a priori pruning principle, if there is an item set which is not frequent, is infrequent, then all its superset will be infrequent as well. So what does this mean? We can use this example to illustrate this principle again for you here. So we know, right, according to L3, we know that this ADE is not one pattern inside this L3. In other words, we know that this ADE will be infrequent. According to the principle we showed in the previous pages, we know all its superset will be infrequent as well, right? And in other words, by adding any charts or items into this ADE, all its superset will be infrequent. For example, this ACDE will be infrequent, right? So, this ACD is generated by joining ACD and ACE together. However, we know that this ADE is not in this L3, and all its superset will be infrequent, including the ACDE, right? Because this ACD is a superset of this ADE by adding this C into it. So therefore, by checking all the infrequent patterns, we can do a pruning based on the self-joining result, and which can help us generate C4, denoting the candidate sets involving some candidates of the item patterns or item sets with 4 items. So this is the way we do the generation of these candidates in the a priori algorithm.